Hey everyone, welcome back to our channel. Today we have an exciting topic lined up for you. If you have ever wondered why your Python code is running slower than a snail, don't worry, we've got you covered. In this video, we'll learn all about Python code profiling and how to transform that sluggish code into a lightning fast powerhouse. So let's dive right in. Before we jump into how to do it, let's understand what Python code profiling is all about. So, Python code profiling is checking the performance and memory usage of different parts of your code. This one actually involves running the code and recording various metrics such as the function execution times, memory usage, and the number of times each function is called. It actually helps you find the slowest parts of your code that might be causing the delays. And there are so many profiling tools that can show you which functions or lines of the code are actually the culprits behind the slowness. By identifying these slow parts, you can work on making your program faster and more efficient. So there are so many profiling tools that you can use to do your code profiling, to analyze your code. There is one which is within Python. It's a module called cProfile, but there are also some third-party tools which is line profiler or memory profiler. Those can also be used for the same purpose. Today we'll focus on cProfile and see how we can use it. Let's look at it. So the first step is we'll import the cProfile module into our script. Then we'll add this cProfile run function to the section of the code we want to profile. Step 3, we'll run the script. Now after running the script, cProfile will actually generate a detailed report showing the time taken by each function, the number of calls, and many other details. And now that we have the profiling report, we can decipher it and find those performance hogs, basically the ones that are causing the delay. While we are analyzing the report, we'll actually look for function with the highest time per call values because they are the ones which are taking the maximum amount of time while the code is running. And we can additionally also check for functions with a high number of calls. These are the ones that are called multiple times, so even if they are a little bit slow, it is compounding to a lot longer time. Now there's one more thing that we can do. We can try to make output of the cProfile function more readable and useful because it has so many details cluttered. You can use pstat library. This is a built-in module to analyze the profiling data. So this is made for that purpose. If you run the code that I have displayed here, it will display the top functions that consume the most cumulative time during execution. I have put 10, but you can adjust the number in print stats function to see more or less number of entries. Now once we have identified the slow parts, it's time to optimize the code. There are different optimization techniques that we can try. One thing we can try, which is we can use more efficient algorithms or data structures, and we can use some algorithm which is internally multi-processing the code, or it is using a different kind of a data structure which is more effective, which is more efficient in terms of performance. Then the second thing we can try is, which actually helps a lot, is we can cache or memorize repetitive calculations. If there is a table or a number which we are calculating multiple times, we can cache it and reuse it so that the code does not run multiple times to calculate the same thing, to derive the same thing. You can explore the vectorization possibilities that will make your code very faster, and especially when you're dealing with large data sets, try to experiment with different kinds of data types, convert your data to vectors, try out list comprehension while you're writing the codes, and especially when you're dealing with large data sets, try to see your data types and see if you want to convert those to something else which is more memory efficient. Try out these techniques based on what is appropriate to your scenario. After implementing the optimization, we can see the results, and then what we can do is we can profile the code again using cProfile, check if the changes made any difference. By comparing the old and new profiling reports, we'll actually know how much exactly we have improved in terms of the code's performance. And there you have it. We have learned how to identify performance bottlenecks using cProfile. We explored various optimization techniques to make our Python code faster. So the next time you encounter a slow Python program, you will know what to do. If you found this video helpful, don't forget to hit the like button, subscribe to our channel for more exciting Python tips and tricks, and share it with your fellow developers. Thanks for watching and happy coding. See you in the next video.